discuss about RSTP. RSTP, also known as Rapid Spanning Tree Protocol, is an evolution of its predecessor STP. It was introduced as standard IEEE 802.1W. RSTP is backward compatible with STP. One of the big disadvantages of STP is its slow convergence after a topology change occurs in the network. And to overcome this, RSTP was introduced, which significantly reduces the convergence time. Let's go ahead and look at RSTP port roles. RSTP defines different port roles as follows, starting with root port, a forwarding port that is the closest to the root bridge in terms of path cost. Then we have designated port, a forwarding port for every LAN segment. Then we have alternate port, a port that replaces a root port when it fails. This is a switch port that offers an alternate path towards the root switch. Then we have backup port. It is a port that replaces the designated port when it fails. This port comes into picture if you have a scenario where a single switch has two links to the same segment, that is same collision domain, such as hub. As shown in the topology, you can see switch 2 has two links that connects to the same hub. Switch 2 port FA0/3 happens to win the election as designated port. The other port on switch 2 that connects to the same collision domain, FA0/4, acts as a backup port. So with a backup port, if the current designated port fails, switch 2 can start using the backup port with rapid convergence. Then the last port we have is disabled port. It is a port that is administratively disabled, and this is a port that has no role within the operation of spanning tree. Let's go ahead and look at some of the RSTP port states. The RSTP port states corresponds to the three basic operations of a switch port. These states are defined based on whether a port can forward user traffic and learn MAC addresses. Unlike STP, which has 5 switch port states, RSTP reduces the number of port states to 3. Starting with discarding state. When a device is connected, the port will first enter this state. Basically, it combines the blocking and listening port states as in STP. The port does not forward user traffic or learn MAC addresses. The next state we have is learning state. In this state, it receives and transmits BPDUs and learn MAC addresses, but does not yet forward frame, same like in STP. And the third state we have is forwarding state. In this state, the port learns MAC addresses, receives and forwards data, receives and transmits BPDU, same like in STP. These are the states in RSTP. Now, let's try to know what is RPVST plus. As you know, RSTP, like STP, runs a single instance of STP for all VLANs and will have a single root bridge for all VLANs, which overall impacts network utilization. So RPVST is the solution for this problem, and it is a Cisco proprietary version of RSTP. So Rapid PVST plus or RPVST is an independent, it has an independent instance of RSTP that runs for each VLAN. Each RPVST plus tree can have a different root switch and therefore can span through different links. Since different VLAN traffic can take different active paths from multiple possible topologies, overall network performance or utilization increases. So that's all about RPVST plus, and that's it for this session. I hope this was